Hello, today I would like to talk about entanglement, and probably you heard about entangled. Entangled is a kind of for example, the relationship entangled to each other or an event entangled to other things. But today I'm talking about the physical things. It's a physical terms. I will explain and give you an example about what is the entanglement. And I won't use a traditional way to explain this because you can find a lot of videos to use a similar way to explain it, or you can Google it. You can find some similar things. Today I will use a different perspective to explain this. We have two boxes here, and we have a pair of gloves. We put one glove into one box. Sorry, big drawing. And this is the left hand side of glove, and this is the right hand side glove. The fingers numbers right? Never mind. Okay. So we have two teams. I don't know. I didn't tell the team which glove puts which box. So one team bring one box to the North Pole, and the other teams bring the box to the South Pole. And as a team in the North Pole, I said, please open the box. And they open the box and they see, well, it's left glove in the box. So I don't have to tell them, they already know. The other box in the South Pole, inside there is a right hand side of glove. They don't have to guess. How do they know? Well, because it's a pair of gloves, right? So this distance, if you think this distance is not far enough, we can make an example like this. The same things happens here. So I put a black box in the galaxy here, and I move the other box to the other galaxies. They may distance far away from each other 32 light years. So that's far enough, right? So the amazing things happened. If I open this box, I realize that there is a right hand side glove here. Then I immediately know the other box in the other galaxies, even far away from our galaxies, is a left hand side of glove. No one can say no, it's not. Alright? So I can know the things simultaneously. This in a very far distance. In physics, we have a very special term to describe this phenomenon. We call it non-local. Alright? And in most textbook, the example that you can Google or find out in YouTube, they use electron to explain this entanglement and non-locality. They use the electrons. We have a pair of electrons here, and one spin up and the other is spin down. So I have more physics terms here. So we have spin and we have angular momentum, if you don't know what spin means. And we don't talk much detail about that, but here's what I try to say is they share the different directions, but the most important is they are a pair of electrons, which means if one spin up, the other one must spin down. The same, we put them into two boxes, and we don't know which one we put which box. And the same experiment, I can repeat it again. I put one box to the South Pole and left the other box to the North Pole. Even the galaxy is the same. When I open the box in the North Pole, I see, okay, the electrons here in the box is spin down. Then I simultaneously realize that the other box in the South Pole has a spin up, electrons stay inside. It's the same conditions, right? We just switched a pair of gloves to a pair of electrons. So you probably will say, well, that's the same thing. But if the things is so easy, then we can case close here. We don't have to mention about entanglement. We don't have to mention about non-locality. Even we don't have to mention about a lot of things. These differences here are the scale. A pair of gloves is a product in our daily life. But the electrons, we cannot see electron in our bare eyes, right? We cannot touch it, even if everywhere in our body. They are so tiny, they are so small. So basically, they are in a very small scale. We call it microscopic. Or they only can be understood by quantum mechanics. So because they are so tiny that we cannot see it by the bare eyes, so we cannot know if these electrons spin up or spin down. We have to do something to make sure what's the spin direction. That is the measurement. We have to do the measurement to make sure the direction of the spin of the electron. But we don't have to do the measurement to the glove, right? Because we open the box, we already know, we can see the glove in our eyes by our eyes, but the same thing cannot happen on the electrons. So we have to do the measurement. But unfortunately, in such a small scale, the quantum mechanics, people found out the case is not so easy, because any kind of measurement in such a small scale, we call it a quantum scale, the measurement behavior will interfere to the system, even to the electron, a single particle. So we do the measurement and we interfere with it. Okay, it sounds like we do some strange things about a glove. We deposit it and we try to composite it again and make it become the right hand side of glove, not left hand side of glove. It's just like some weird behavior, but it happens in the quantum world. So the measurement makes something different, and comes along with the measurement. There is another feature of the quantum world, is we circled it an uncertainty relation. It states that we cannot have precise measurement of the position and the momentum, same as the energy and the time. All right, I won't talk about detail about this, but let's stop here. we just focus on the measurement. So we already know that the difference between these two examples, the pair of gloves and the pair of electrons, is a measurement. And the measurement behavior will interfere with the state, with the systems here. And this makes everything different compared to our daily life scale. So here's a problem. The same questions, I switch the glove inside the box to the electron, and I do the measurement here. I don't know before I do the measurement, I don't know if the electrons stay in this box spin up or spin down. But after that, I finished the measurement, I realized that the electron in this box is spin up. Then I don't have to do other measurement. This box, the electron in this box simultaneously becomes spin down. Please notice that the word I use, becomes spin down, which means it probably not spin down, it probably spin like this or like this in different directions. But once we're so sure that one box here in our galaxies, the electrons spin up, then the other ones in the other galaxies, the electrons spin down. Even it stays like this or like this in different directions, pointing to different spin directions, but this measurement can influence the other electrons regardless of the distance. That is the meaning of the non-locality. And this is very weird because if we put them far away enough, then the information transfer might over the speed of the light. But according to the relativity, we all know that's impossible. So how does the information pass on through such a distance with a limited velocity, but still can forward to far away galaxies? We don't know. So the non-locality is a one very, very interesting topic in quantum mechanics. And here, distinguish between these things, the pair of gloves and the pair of electrons, is, let me think, where can I write down the words here? Here. Deterministic. All right. In our daily life scale, the pair of gloves is deterministic because we already know that. We don't have to know its right hand side or left hand side by do any kind of the measurement. But in quantum scale, quantum world, the deterministic in this case is different. We don't know the stage. We don't know the spin direction. What we can do is to do the measurement. And it is this deterministic property distinguish, always draw the gap. Okay, the gap here between our daily life scale to the quantum world scale. So why the quantum world is not deterministic? Well, I have to be careful to use this word because someone talked about this on Facebook. They talk about deterministic and the causalism, but they are two different things. But now here is deterministic. So basically, I explained the concept of entanglement and the difference concept between our daily life scales and the quantum world scales, and we need to do the measurement to the quantum world scale, and this measurement produce something very strange results, non-locality, and also a lot of the features that we cannot understand or be understood still now. So I think this is a short talk here. I hope you liked today's introduce of the entanglement, and I hope you won't be so entangled in any kind of event or the relationship or something like that. And so I think that's it. So I'll see you next time. Bye bye.